I was just making sure that this is still going. Well, it is uploaded. I uploaded it. I was just wondering if it's still there. Oh yeah, it's still here. It looks like I'm still sharing my desktop. See the same screen. So is it recording now?
Well, yeah.
Yeah. And this is on stop. It is recording. Okay. So we can minimize that. This one's almost done uploading actually. All right, so I'm not sure on your end what's gonna happen, but the lecture definitely recorded, and I'm uploading it to YouTube right now. So we'll have that as backup, and now we'll do the lab, and that'll almost for sure be recorded because, you know, why wouldn't it be? Because the lecture was recorded. So hopefully we'll have that as backup because it appears that the power's still out there, right? Okay. All right. Well, yep. So like none of the computers work. Just for some reason, just the IVM's working.
Yeah, it's on a power source. We have so it's for certain. This is news to me. The building's not. I guess not all the same breakers. There's different breakers for the building. So certain of the rooms up here still have power, and the room next door is one of those rooms. So I'm thinking the TV and the IVM system must be on that same circuit or whatever.
Right. Yeah, seems weird. Yep. And then there's something that's on battery backup because it's going beep 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 beep.
Well, that's the server we have in that, and then actually got two battery backups. Instructor computer up front, but that's yeah, never mind. I was thinking we might be able to do something off of that, but the projectors doesn't have power, so there's the batteries away.
Okay. All right. Well, this will be really small on your end, but right, because it's still on the TV.
Yeah, we can't see your screen at all.
Yeah.
It's just all. It's white.
Yeah, it's too washed out.
Oh. Okay. All right. Well, I really hope that this is. Yeah. I mean, we can look at. If this doesn't record, we can look at other solutions. But so I actually have a map document in the data for this lab. So if you download it and unzip it, you can open that map document. I'm going to close that one because this one will go ahead and open. I think it's opening. All right, there we go. I opened it twice. No, I didn't open it twice. I opened There we go. All right, so if you open it and like me, you get little red exclamations. I thought I fixed this. Okay, what's going on? Why do I get red exclamations?
Doesn't have access to those layers.
Right. So maybe I opened it right from. I opened the Lab 4 ArcMap file. So the way that you can repair these, double click on the source and then choose source, set data source, and find the directory. So mine are under C temp. Think where'd I put them? Yep, C temp SA Lab 4. Data source. All right. I can do that with the destination. Once you choose one of them, the rest of them it'll stay in the same folder. And then elevation. All right, so this landmass is Europe, which most of you probably know. So this is like a simplified version of the lab. I mean, I didn't simplify it, but what I'm trying to say is I made a fairly simple lab so that the concept could be pretty easily understood. So unlike the railroad example, there aren't a lot of costs that we're going to utilize. We're going to make this fairly simple, and we're going to build cost. It's still going to be multiple layers, so we're going to have to add those layers together. So for this lab, we're going to design a GIS model. Like the other labs, you're going to turn in a toolbox. Okay? Your toolbox is going to allow the user to specify the cost for traveling over various conditions. Oops. All right.
You already opened it.
What's that?
Never mind. I don't even know.
Oh, go ahead and ask.
I have a question I don't even understand. I'll reformulate it.
Oh, I'm trying to figure out. Yeah, that's right. This button turns down. Okay. So yes, I opened up ArcMap. The layers didn't naturally open for me, so I had to change the sources. Okay. So the user has to be able to specify cost. I'm trying to stay over here so the video gets my voice. To specify cost for traveling over the following land cover types. You should make these a parameter in your model. So the end user should be able to specify what the cost is for traveling over water, for traveling over open areas, and for traveling over forests. So there's only 3 land covers. We could have more land covers and different costs associated with each one of those. So in addition, the user is going to be able to specify the costs associated with traveling at higher slope values. The higher the slope, the higher the cost. Basically, it's a multiplicative cost factor. So in other words, you're going to let the user specify what the cost for traveling over water is, what the cost is for traveling over open areas, what the cost is for traveling over forests, and then you're going to let them specify a multiplier for slope. In other words, slope times whatever they specify is the cost for traveling over different slopes. All right. There are values in the elevation data set that are no data. Okay? You'll need to recode those values at some point so travel can be made over water. In other words, your slope value should not be no data over water. It should be something else, 0. So you can use the is-null function to get around that. So lastly, your model will provide a transition cost between land and water. So kind of like, if you had to change between your mode of transportation, that would cost us some extra. So the cost to transition between different modes of transportation. And it's a little trick to implement. You'll have to use a neighborhood operation. You use a majority operation coupled with a condition operation to find those areas that need to have an extra cost associated with them. In other words, where the land-water interface is. And then you have to provide use the provided data. So now my phone thinks I was talking to it. Okay. All right. So you're going to experiment with several values until you find one that chooses a mostly overland route between Copenhagen, Denmark, and Venice, Italy. They're already the ones that you've chosen. Copenhagen is on an island, so some of it will still go through water. And so this could be a scenario where you were like trying to find a probable migration route between two locations. It might in reality need to be more complex, but we're simplifying it down a bit. Although there are still some intermediate steps that we need to take. So what I would like to do together, to work on this together, is to set it up so that you have the input parameter values that you need as input parameters so that the user can specify those values. Now what I can do is when I'm done, I can upload the toolbox, the starting point toolbox, up into onto Canvas so that even the coach people have it. Everybody has it. So what I work on, we can upload that. Okay? And then what I also want to do is come up with, we won't implement it in the toolbox, but we'll come up with how we could do this part of it, okay? How we could do that part of it. And also come up with the slope multiplier, just like basically demonstrate how to do it in our toolbox, because once you do it in our toolbox, you could drag those tools on to the map. All right, so there's the data the way it should look like. I'm going to yes, both the source and the destination should. Yours is not? What does the destination look? Does it even say destination?
It does say destination.
Does it have a little red exclamation point next to it?
No, it just has a little red circle below it. And a red circle.
It gets it wrong, but not for destination. destination, and source. In other words, you said source, not destination. All right, so let's look here. So yours isn't showing up. Showing up. You just used map. Yeah. All right, Adam, was that you that asked the question? Source and destination should show up.
I removed them, re-added them, and I got them in 2 different locations.
You do have them in 2 different locations now. Okay.
Yeah, one's like to the east Denmark, one's sitting right on the tip of the
Right. Yep. Good. All right. Yeah. So up here, and I could see how you could do this. You make sure you choose source for source and destination for destination, because if you don't, they'll be right on top of each other, and it'll appear as though one isn't there. So that's what happened here. So, okay. See, like.
calculators, your tools open, or you just got the map pulled up?
So far, I just have the map pulled up, but what I'm going to do now is create a new tool in our toolbox. And I'll create this. I'll go add toolbox, right click in our toolbox, add toolbox. The tool doesn't exist yet, so I have to navigate. I'm going to keep everything together. So in my case, I have temp SA lab 4, and I'm going to create a new toolbox. And I'm just going to call it lab 4. So now I have my new toolbox there, and I'm going to choose it and select open. So now I have a tool in my toolbox called lab 4. This is the tool that I'll upload, the toolbox that I'll upload for anybody that wants it. And so next, I have to add a new model to this toolbox. So I'm going to right click on it and say new model. Okay. I'm immediately gonna close it. Sorry, was there a question?
We got power going back.
Awesome. Yep. Now it's like the lights turned on. I mean yeah. I guess you're right. Now, yeah, but the light came on slowly. Didn't it seem like it came on slowly?
Maybe it was the last time.
But if the cameras were on, we would see the window.
Yeah, that's what I'm saying. It almost looks like the sun just turned back
It
on.
was just like a waiting. Yeah, it was so funny.
Camera move. Yeah. This is
All those dark days.
So I'm just going to rename this this model. That's what I'm going to do. I'm going to rename it cost distance. Cost distance is not a good thing. I'll call it migration or something. Doesn't really matter. Migration model. Do you want me to wait about 5 minutes until everybody's computer turns back on?
Maybe so. It looks like the jacking is warming up or whatever it's got to be. I think it's all white. Right. Never mind, it's got all down.
Yeah, it doesn't really matter what you call it.
Do you want, I forget, do we click store relative path names or no?
I always like to.
What was that?
Yes, I always like to. Okay, so store relative path names, what that means is that for whatever I'm talking about, whether it's my my toolbox or my map document, that's saved in a location, right?
Yes, sir.
Yes. So that location could be C, George's Docks, Lab 4, right?
Yes, sir.
So anytime I add data to my toolbox or to my map, it has to store the location of that data. It doesn't actually save the data, right? I mean, an ArcMap document doesn't actually save the location of data. It only saves, it doesn't actually save the data, it only saves the location of that data. And so the absolute location would be that it's stored C:/George's Docks/Lab4/data, whatever the name of the data is. That's the absolute location. If I instead stored the relative path, I'm only going to store the location as it relates to the item that was saved. So if it's a map document and I saved it in that location, and I saved the file data.shp and in the same directory, all it's going to save is data.shp. If I save it in a subdirectory called data, then it's going to store data/data.shp, not the entire path, just the relative path. So what that means is if I move to another computer and put my data on a D drive instead of a C drive, if I didn't say store relative paths, if I said store absolute paths, it would say I can't find the data. It's supposed to be on C, George's data, whatever, blah blah blah, data.shp. I can't find it. You don't even have a D drive on this computer.
Right.
And so,
that's really why, without doing that, I'm having issues if I work on it here in the lab on a computer on my thumb drive and take it home. Probably because I haven't been stored relevant pathways, so the C drive or whatever.
yeah, I mean, it's certainly one reason why you would have a problem if you tried to move it from computer to computer. Unless you store it in the exact same entire path, it's not going to be able to find the data. So like, I'm saving everything in the C temp. If I went home and created C temp on my own computer and put all the data in there, I wouldn't have a problem whether it was absolute or relative. But if you're saving it under, C, documents and settings, users, desktop, users, and then whatever your W number is, desktop, that's not going to exist on your own computer.
Right.
But you can just change your default geodatabase to wherever you're saving it.
Yeah. Yep. You can do that too. So that's the difference between relative paths and absolute paths. All right, so migration model. I'm going to edit this. All right. Now, we haven't done a lot of this yet, but this is one of the requirements of this lab is that we're going to start utilizing the setting of parameters, or the creation of parameters that the user can change. This is one of the reasons why Model Builder is so neat, is that you can make up your own parameters and then change them when you actually want to go to run. So we want to come up with the parameters for the cost for traveling over water, the cost for traveling over land, and the cost for traveling over forests, open areas, and water. Those are the costs. We also want to set a multiplicative cost for the slope. All right, so we want the user to be able to specify those values. So what we can do is we can start dragging things on here, but we can also insert variables right into the map and into the into the model. So we could create a variable of any type that we want. Okay. No, and a number is going to be what we're going to use because these are all going to be numbers. Okay. We've got one type of number is called a long. It's a long integer. One type of number that we could add is a I think we can call it. I think there's a float. Do you have that? Maybe just a double. Is it going out again? Okay. I was wondering what, yeah, there's double right there. So that allows us to specify a decimal number. Okay. So I didn't really specify in the lab whether I wanted you to be able to express costs as a decimal or not. But I think it might be easier to not express it as a decimal. Because really we can enter in whatever values we want. So if we want to go really, really high, we could just say 1,000, and really, really low we can say 1. So we still have a wide range of costs. So I'm actually going to stick with a regular, I'll go with a long, which is a long integer. So I could say, okay. So this is the variable that's going to accept one of the costs. So in order to make this a parameter, I need to right-click on it and say model parameter. But first I'm going to rename it something. I'm going to right-click on it and rename this. And I'm going to say, I'm going to call it like water cost. Water cost. See that? Okay. Then I'm going to right-click on this guy and make it a model parameter. So this is the cost to traverse water. If I save this and close it, when I double-click on the migration model, now I have the option to specify a water cost. Okay? And it'll make me choose a number. If I put in a decimal place, it disappears. So if I make it 2, it takes it as valid. Okay? I'm going to hit cancel right here and go back and say edit. So now I've got my water cost. I can double click on it and set a default value. So I could say that the default value is 2. Now every time I try to run it, there'll be a default value there. Right? So I'm going to do that 2 more times. Well, really 3 more times. And now I made it too big. There we go. I'm going to do it 2 more times for the other types of cost. And then finally, I'm going to create 1 more for the cost associated with the multiplicative slope factor cost. All right, so I'll do this again. Create variable. I'm going to make it a long. Whoops.
If you just copy that one and paste it, does it save all those variables?
Yeah, I mean, you could do that and it might be faster. It's a good point. Control V, Control C. It doesn't make it a parameter. And I will have to but I could rename it and call this land cost. Or no, open cost, traveling through opened area. And then make it a parameter. Okay, so that's an option. I'm going to do the last one just by saying create variable again. Right click, create variable, make it a long. But if you copy and paste it, it'll be a long. I think that was your question. and then rename it. I'm going to call it forest cost, traveling through forested areas, and then make that a model parameter. So now the user can specify all of those parameters and make that, I'd have to go in there and I'll come up with a cost, a default. I'll make it 5. Costs more to travel through a forest than the water. And the open area, right now costs are the same, but change that. So I made this cost 2, this cost 2, and this cost 5. So now if I save it, exit out, and I do a migration I open the migration model, see it has me able to specify these costs, and I've got the default values. So right click, edit.
So you did put 2, 2, and 5 in?
Yeah, those are just, you're going to experiment when you actually go to run it, but those are just the default values I came up with. If you want to use different default values, go ahead. That's not vital.
When you say quote as 0 on the text, is that what you mean? Concept? On the left direction.
Oh, already used.
I think that's just telling you what land cover.
So that's what I mean.
No, the cost is like arbitrary right now.
So yeah, now you're close. You just need to close. All right, Ella, did you have a question? All right, if you've done that so far, why don't you create another variable called slope multiplier for slope cost or something like that. I guess probably just slope cost is fine. It is recorded. I'm sorry, what?
Stuff like slope multiplier.
Yeah, I think slope cost might be easier to understand, but we are gonna multiply it in the end. So I'm gonna create variable, and here, since slope, I didn't say in the lab, but since slope is already like a number that can get higher or lower, I think it might be better to allow the user to enter a value that could be a decimal, because it might be that we want to make that value more precise, like a 1.5 multiplier, something. Anyway, I made it a double when I did it, but again, it wouldn't be bad if you didn't. But I made it a double, and I'm actually going to put 1.5, but you could put 2 if you didn't make it a double. Oh, I'm going to rename it slope cost. And then finally, we're going to make one called transition cost. which is going to be transitioning between the land and water. So we'll need to find out how we're going to do a land-water transition. That's the other thing that we'll need to do. So I'm going to create one more variable. And make this a model parameter and rename it transition cost. Transition cost. And I'm going to make the transition costs, high, like 10. It's going to cost a lot to go between land and water. But you'd only be doing that once. Okay, so I've got all 1, 2, 3, 4, 5 bubbles here. Transition cost is the last one. It's a long. I made it a long. Did I make it a parameter? Yeah, I did. It just wasn't refreshing. You ever play solitaire at the end? It's like. I wonder why it's doing that. Okay. So the next thing that we need to do is, I'm going to go ahead and save this. All right. The next thing that we need to do, that I said we would do, is talk about the transition cost. Actually, before we do that, let's talk about how we even get these things into our models later on, right? Because we kind of went over that, but kind of it wasn't. It was in the readings, but it wasn't explicit. So we haven't actually talked about what slope is yet, but you probably know from other GIS classes that you can calculate slope. So I think the easiest way to do this is with the slope cost. So if we go to our, if we go to Spatial Analyst Tools and we choose Surface, there's one called slope, which is what we're going to do here, slope. All right, so when we run slope, we're going to get a slope value from the initial value, and what we want to do is actually multiply slope by the slope factor. Okay, so this is like a pre-step. So really, we've got our elevation data set. We want to calculate slope, and then after we calculate slope, we want to multiply slope by this to get by our slope cost to get the value that we're going to include as our, I'm reusing the word now, but that'll be our actual cost for slope. All right, so we got slope here, and we could just set this up as the user is going to have to use the elevation data set that we're providing. So we can just choose that elevation data set. You can either choose it here, or you could choose it from the data. Elevation, and then you could specify where you want to put it. I'm just going to put it in the same folder and call it slope. All right, so that's going to calculate slope. Right? I mean, that's something that you've probably done before, but even if you hadn't, this is just running a single tool. So what we want to be able to do is multiply slope cost times slope to be slope cost everywhere. Okay? That's what we want to do. So what tool can we use to do that? There's a few that we could use.
Real quick, Dr. Redwood,
Yeah.
did you change on that slope calculator? We use binary feedback.
I didn't change any of the defaults. I did specify the output raster location as in the same folder I've been working on.
Yes, sir. Thank you.
Yeah, but I didn't change degree. I didn't specify in the lab, but it's a multiplicative factor, so you can change it. Yeah, here. Oh, you need to turn on which one else? Go to that's minus. Turn on position. Okay, so getting back to my question, what do we need to do to multiply? I mean, yeah, well, what tool can we use to multiply slope times slope cost? Yeah, under math, there's one called times. We could use that. And then from the coast, I heard raster calculator. We could use either one. Now, if you remember in the lab, there's another step that we have to do, and that is that we have to change all the null elevation values to 0. Okay? So that's all these values up here, because look, if we turn off, not source nesting, if we turn off land cover, all these values are no data. If we leave them no data, when we combine the costs later, what's going to happen? It's never going to go through water because the no data values mean there's no way to get through it. So we need to run the is null tool and with the con tool to get those out. So what's that?
That's what we did last lab.
Yeah, we did that last lab too. Good. So in other words, what I'm trying to say is we could do those as two different raster calculator calculations, or we could just combine them, like as one raster calculator calculation. Then we only have one item there. So that's the route I'm going to go here. But in any case, it would be the same. So I'll just do the times. Don't follow me right here, but if I wanted to do them as two different steps, notice that I can choose, or I can't choose. Okay. If it doesn't let you choose, let's see if this works. We're going to do it as a raster calculator version, but times, why doesn't it let me choose slope? Oh, I'm not in the model. You're right. Okay, I'm going to throw it onto the model. Thank you. Okay, so now it will let me choose any of these costs. See that? So I can choose the slope cost and then choose the slope output. And then it would do the multiplication and it would work. Okay? So that's one way to do it, but I would still have to run a map algebra expression anyway to do the other step. So we'll just do them all together, and it's a little bit different when you do them all together. It's actually a little more complex, but not much. That's why I'm doing it that way. Okay, so let's go. Where is map algebra? Raster calculator. Move that on to the equation. All right. Now, remember before when we did the little percent, whatever percent. Okay. Watch when I choose slope cost, what it does. I'm going to choose slope cost. See how it changed that into percent, slope cost percent. So that's the actual syntax for inserting slope cost into the equation. So you could manually type it if you wanted to. But when you do a percent, variable named percent, you're telling it to choose a variable value. And then what this means is it's converting it to a float, which is safe to do most of the time. So I think it's just adding code for you. It's not technically necessary, but let's just leave it in Because what that does is it forces the output to also be afloat and continue on, and so to have a decimal place. Okay, anyway, so that's that, but that's only one part of the equation. We want to multiply it times the slope, right? And we also have to change the slope. So if I say multiply by this slope data set, that would be almost there. It's not quite there, right? We still need to do the conditional statement. So we'll do con, and then is null, and then the slope. So what we're doing is we're saying if the slope data set is null, and then we put a comma. If it's null, what do we want to do? What value do we want to assign it? Yep, 0. Okay, because there's no additional. It's the same as if the slope was 0 on land. Okay, slope cost isn't part of it. There's no concept of slope on water. So if you want to increase the cost of water, then just change the water cost. Okay, we just want there to be still cost over water. So 0, comma, and if the value is false, in other words, if it's not null, what do we want the slope value to be? I mean yeah. What's that? What'd you say? What'd you say, Adam? Oh, no clue. Okay.
The elevation multiplied by the cost.
Well,
The
the
result
slope.
of that.
Yeah. This is slope. So in other words, if the slope is null, no data, assign a 0. If it's not, leave it as the original value, the slope value. It's the same, almost the exact same thing we did last week with elevation. If that might be too small. Actually. All right, so that's what it is. Now your variable name might be different. I don't know why mine's slope 2, but that's what mine's named. But that should be the formula. Now, something Elida said actually made me think that we could make the formula different. And maybe she was saying this, I don't know. What I could do here is actually say slope 2 times the float right in there. Yeah.
That's what I understand. What was con is null? I thought you were just going to take the slope cost and multiply it by the slope calculation.
Right. Okay. That's a great question. So what I'm trying to do is say in areas where the slope is null, there's no data, make those areas 0. Otherwise, make it the slope times the slope cost. So that's what the con is all about. It's a conditional statement. It's an if-then statement.
I get it. Wait, should we know this syntax? I don't know about this, the classes functions. I mean, I'm familiar with programming terms and everything, but it's conditional, it is no operation stuff.
Yeah, well, I mean that's what we're doing. I mean, some of the readings, talked a lot about all the different functions. We've covered both con and is null in classes. And then the syntax is kind of like just clicking buttons, right? Like, I didn't actually type any of this. What's that?
It's a conditional solution.
Right. So the con statement, these are local operators. The con and is null are both local operators, and so is the multiplication. And what Elida just pointed out is that I could have put that there. It's just a different way, but it would produce the exact same result. It would have produced the same result. So what this conditional statement says is if this condition is true, the output value, the local output value will be this value. If this condition is false, the output value will be this value. That's what the conditional operator does. So anyway, if somebody wants to experiment, if that one works, if that other one works better for you, they're equivalent statements.
I forgot the cost was already speaking of multiplication.
Oh, okay, I see.
Yeah, the multiplication doesn't change the order.
Right. The reason why the multiplication doesn't matter is because 0 times anything is 0. So I'm going to put this in the same directory. No, I don't have that anymore. So that was C temp. Is that where I put it? SA lab 4. Yep. And data, and then I'm just going to call this. I'm going to call it slope cost value or something, just so that I don't confuse it with the slope cost input. But this is what it's saving it out on disk as. And then I'm going to say OK. And I'm actually going to run the model up to this point just to make sure it works. That there's no syntax error inside of my raster calculator, because sometimes there can be. Okay, it looks like it's running. Yep. It didn't add it to the model. I mean, to the data set. I could maybe add it to the display. All right. Maybe that's a little small, but that is the slope cost. Why in this area is the slope cost higher than it is almost everywhere else? What feature is that? What?
Alps, right?
Yeah. What do we call those mountains?
Alps.
The Alps, yeah. They got the Matterhorn. When I was a kid, I worked at Disneyland, so I knew all about the Matterhorn. But that's the only feature of Disneyland that's actually visible from outside the park. Walt made it like self-contained, so you can't see out, you can't see in. But you can see the Matterhorn from the freeway. All right. Not that Matterhorn, no. Okay, so that's the Alps. What are these mountains called right here? They have a name too. But anyway. All right. Who knew it was so slopey up in Norway here? Well, I mean, I guess they have got the fjords and stuff up there. All right, I'm going to go ahead and get rid of the slope cost. Open back up the my model, lab 4, edit. All right, so that is that, okay? All right, let's talk about some strategies. So that's this right here is all ready to be added with all the other costs, okay? So you're going to have to come up with another cost here, right, to get to this strategy over here, okay? I mean, to get to this cost. You're going to come up with a strategy to get to this cost. And then finally, this one will be the most complicated, so let's actually do that one together. Well, let's talk about, before we do that one, let's talk about some strategies for doing this one. So basically, we need to do something like say, all we ultimately need to do, we got our land cover, let's turn it on. We need to turn zeros into the water costs, we need to turn ones into the open costs, and we need to turn 2 into the forest costs. So what are some ways we could do that? There are several ways to do it. So it'll be interesting to see on your models which way you do it. But let's go ahead and say, what are some ways in GIS that we can convert numbers to other numbers? Go ahead. Sorry, Adam, you were about to ask a question?
Yeah, what exactly are we trying to do?
So we want a new raster in every grid cell where it was a 0, we want it to be the water cost value. And in that same raster, everywhere where it was 1, we want it to be the open cost raster value. And everywhere where it was 2, we want it to be the forest cost value. So we just want to convert 0, 1, and 2 into these values. Yeah, go ahead. Sorry.
I thought the user was inputting.
They are. So these are variables. They're standing in place of the user value for now. So what I'm saying is, whatever the user enters as the water cost, we want that to become 0. And whatever the user enters for open cost, we want that to be 1. And whatever the user enters for forest, we want that to be 2.
Can we reclassify this?
Yeah. We can use the reclassify tool. That's what Elida said up here. And that will work. It will work, hopefully. I don't know if we can actually enter in, like, reclassify value. Let's see if it'll work. I'm pretty sure it'll work. Reclassify. Let's do that. That's one of the tools, right? Reclass. So if we were to say the land cover, and 0, 1, and 2, the new values, can we type in percent water cost percent? Let's see if that'll work. I'm not sure it will, but I'm going to try it out. Okay.
No, I think
You think what?
I think you have to go to
This one?
yeah, like try. I think after this align, go to the class. Yeah.
You mean hit this guy? I still don't think it'll let me choose those values. I'll bet you there's another reclassify tool we could use. What does lookup do? No, that doesn't really work. Doesn't look like it would work. Classify by ASCII file. We could like write a little Python script that put it into an ASCII remap file, but that would involve Python scripting, and we're not doing that this semester, except for at the very end. We'll talk about it a bit. We classify by table. Table needs a table value. We could probably, if we got fancy, build a table in it, but yeah, I don't really see any of these working very well. Any other ideas? We could use Raster Calculator. What tool inside of Raster Calculator would we use? Could we change? I'll write this a better way. Could we change this problem into an if-then statement?
Zero, whatever.
Right. Else, like we could chain a bunch of conditional statements together, which we haven't done before, but we could do that. Okay. So let's go up here to Raster Calculator. And we're going to come up with a conditional statement here. So con, and then what you just said was if the land cover is equal, it's actually double equals, the equal sign. If it's equal to 0, okay, then what are we going to do? What's the value going to be? Yeah, the water cost, exactly. So we're going to make it water cost. If it's not 0, what are we going to do? This is the part where it might get a little bit tricky because we haven't done it yet. But you can actually say we're going to do another conditional statement. It's called a nested conditional statement. If we're writing a program, it would be an if-then-else statement. So we're saying if the land cover is equal to 0, then make it water cost. Now we're saying if it's not equal to 0, then if the land cover is equal to 2 or 1, then what does it have to be? If the land cover is equal to 1, what's next? Which one's 1? Which cost? Yeah, open, because open is the 1 value. Okay? And then finally, what value is it going to have if none of those are true? So this is saying if this one's true, if it's 0, it's going to be water cost. If it's not 0, it's going to be, we're going to say, is it 1? Then we're going to give it open cost. Do we have to nest another one? No, we don't have to do another one. What's the final value there? If everything else before is false, then what's the output value going to be? It's going to be forest cost. Because forest cost is saying if it's not 0 or if it's not 1, it's going to be forest. There aren't any more land covers. All right? Yeah, that's a comma. So the general form of a conditional statement is con, the condition, then the value of true, the value of false. So what we're doing here is we're saying, check this condition. If it's true, do this. If it's false, do this entire thing. We still need to put in one more parenthesis at the very, very end to match up with that parenthesis. So we're closing this parenthesis and we're closing this parenthesis. So all of this conditional statement is the value if this conditional statement is false. The nested conditional statement. One thing that I don't even know, I should go back and look at the help, or we'll just run this and see if it works. But one thing is, sometimes the conditional statements have to be also in parentheses in some programming formats, some they don't. I forget whether ArcGIS is one of those. What's that? Let's say okay, and I'm going to try to run this and see if it dies. Oh, it looks like it ran. I'm going to add this guy to the display just for a second. And that looks like it worked. Oh, no, it doesn't. It didn't look like it worked. But I just got a 2 and a 5. Oh, that's fine because my values were just 2 and 5. Right? So everything that's land and everything that's open and everything that's water is 2. So that's right. I didn't get 3 different values because I shouldn't have. If I go back up here and change the open cost to 3, then I could try to run this again, and I should get a 3 value. Yep. See, now the open areas have a different value. So I've got a different value, but this didn't update for some reason. I'm just going to re-add it to make sure that, yep. Okay, I just re-added it. For some reason it didn't update. The legend didn't update. It must have been a refresh problem. I re-added it. Okay, So I'm gonna get rid of this guy. I'm gonna open this back up for a second, this raster calculator expression, so that you can see that. Yeah. Go ahead.
So, is the last column just like else, or spouses, or whatever? I'm having trouble with the syntax.
Okay.
So, you know, I'm taking programming, taking crosses, wires. Forest cost, we say, your last column statement.
Right, exactly. Yep. So this is the general format for the condition statement. So if we just did this, whoops, yeah. If we just did that, that's what we're doing there. So now we're saying, if this condition is true, do this. If it's false, do this whole thing. In this thing, we're saying, if this condition is true, do this. If it's not, it's false. So it's the final if statement. In fact, the raster gets this value if both of these conditions were false. Does that make a little more sense?
Yes, that helps a lot, typing it out like that.
Okay.
Get flashbacks, structured diagrams, C++.
Right. Yep. Yeah, I mean, in the end, it's another logic. Yeah, I mean, it's another logical expression. So it's important to understand what a logical condition is, and then chaining together those true and false, those logical conditions. All right. And so I said we were going to do that. I didn't say it. I said we weren't going to do that one together, but we did. The only thing I would change here is that I would store this in the same place I've been storing everything else, which is in here, and I'll call it water. No, wait. LC. I'll just say land cover cost. All right, so now, what's this little guy doing? I guess that's just something that got created from earlier. Okay, now we need to do the final thing. And we'll do this one actually outside of the model. You guys can put it in the model, and then you can add these three costs up, and that'll be the last cost. I mean, that'll be the overall cost. All right? Okay, so outside of the model, let's come up with a way to make a transition, because this was the one I said is tricky. So what I'm trying to do is say, if there's ever a value that is right on the edge between land and water, I wonder, oh, it's elevation. The land cover must be like partially transparent on mine. Maybe it is on yours too. Yeah, okay. So it's got a little transparency to it. I don't remember doing that, but that's why you can kind of see the elevation value through it. Okay. All right. So anyway, I'm turning off the elevation data set, so it's the same. So anywhere where it changes between land and water, we want to make that a higher cost, transition cost. So this is going to require a neighborhood operation. So let's practice that. I said you could use the majority filter. Let's see what happens when we just run a majority filter. That's under neighborhood, focal statistics, and we're just going to do a 3 by 3 because we really only care if there's a transition in that cell range. And we're just looking for the very edge transition. Okay, so keep this as a rectangle, majority. Now, maybe after you see this, see if anybody can come up with why this would work. And this isn't the only thing that would work, but I think it's one that would work when it finishes, or maybe even before it finishes. You could tell me. Majority. I did majority, right? That's actually not going to work. I meant variety. Variety will give me how many different unique values there were. Okay. Variety. Variety gives me how many unique values are. Majority gives me the most often repeated value. So I messed up there. Okay. Land cover. I'm going to run that again. Now this one is going to give me the number of different values. Okay. Okay, so everywhere that there is a transition between land and water, we want to add a cost associated with traversing between land and water. Okay? So you need to make it a neighborhood operation. Why would you need to do a neighborhood operation?
Touching.
Does a local operation even look at the surrounding cells? No. So a neighborhood operation is the only thing that's going to work, that's going to let us look at the surrounding cells. So we need to come up with an algorithm that will allow us to find those cells whose neighboring cells are different from each other. And I said in the lab majority, and that's what threw me off. The variety actually does that. Look what's on here right now. You see how the transition between land and water is highlighted. Now the problem is, and I did know this would be a problem. I actually ran this beforehand. I used variety and everything. I just messed up when I typed it out. The problem is we've also got other transitions, right? You see these? What are these transitions? It's not elevation. This is only run on the land cover.
Okay, it's between the tree and the open.
Exactly. So anywhere that shows up here is a transition between forest and open, and that doesn't require any transition costs. Maybe we could make that a transition cost, but that's not a condition that I said in the lab. So how would we eliminate these areas? Can we do it at this point, or do we have to go back to the land cover data set and do something to it first?
Neighboring operation. Like, can we do another neighboring? Like those things that are values for wind and.
I don't know. Can we? Right. What if we went back to the land cover data set and did something to it to remove, so that we wouldn't see transition between forest and open? What can we do to that data set to remove the transition between forest and open? Exactly. If we coded forest and open the same way, there would no longer be these data sets. I mean, these blue areas. There would only be transition values between land and water. So this is a little forest. This is what this is. See, this is a little forest. This is the boundary of the forest. If we want to get rid of that forest boundary, we have to change the variety value. We have to change the forest value, so the variety value, it won't be different. When it gets to that cell, it'll just say, oh, there's no difference between those two. The variety will be zero. The variety will be 1 because there will be one land cover in the 8-cell neighborhood. Yeah. All right. So here, let's do that, and then you guys can implement it in the model. All right. So we've got our focal. That was the wrong one. Okay. So we got land cover. So we could do it. We're gonna have to do it as a raster calculator. Actually, we could do that by reclass because the user's not implementing anything. So we could do that by reclass and just feed it the land cover and convert the value of these two values to be the same. It doesn't really matter. It doesn't really matter what any of these values are as long as these two are the same. Because variety just says how many different values are in that 3x3 window. Do I have one different value? Then that means that there's no transition cost. Do I have two different values? That means there's a transition cost. So really, as long as these two values are the same, we're good. All right? So I'm going to run that guy. And then now I've got basically a land and water mask. And then finally I run the focal statistics. Oops, not line statistics, focal statistics. And choose variety.
I'm just lost. You're doing local statistics, to running this, to running that. I don't even believe it out of the ball.
Okay. Like these guys?
Yeah.
Those are actually water
Oh.
in the middle of the land, which happens. Those we call them lakes. It's pretty small, but the cost of, like, why would you? I mean, I think we should leave them in there because why would you come up to a lake, build a boat, get in the boat and sail across it? You probably find a way around it. So it makes sense to have more cost associated with that. Okay, so back to Adam's question. Well, it's not really a question, but I recognize that this particular problem, I messed up by saying majority, and so that may have kind of thrown you off there at the beginning, but this is really just a two-step process. So the problem is that we need to find land-water interfaces. That's the problem. Because land-water interfaces are going to cost more in our model. And so in order to do that, we need to run the variety tool. I said majority, but if I said in the lab the variety tool, then I kind of, what I'm trying to do was give you that answer in the lab. So you weren't expected to know that you had to run the majority variety tool or whatever. Okay? So what I wanted you to do was run the variety tool and see the outputs and then understand what it was doing when it ran. Is it that the variety tool isn't explained, like I didn't explain the variety tool very well, is that?
We're good.
Okay.
I think it wants to do like that where we came from.
Okay.
I think the whole process.
Okay. All right, so yeah, now we're going to go back to here. So we need to come up with, we have three different costs. The cost of traversing different land covers, the cost of traversing slope, and finally the transition cost between land and water. So we have three different costs associated with that. So this was basically a reclassified problem, but we couldn't, this one up here was a reclassified problem, but we couldn't just do a direct reclassify because there's no way to allow the user to specify inside of the reclassify tool. So that's why we did this large conditional statement. Okay, I mean, I've actually made conditional statements that are longer than this because, you know, if this, you keep going. Okay, your last one though, back to Adam's previous question, your last one will always look like this, because this is the final. If all the other ones are false, the last one will just be a simple statement of this is if everything else is false, do that one. Okay. The second one, the slope cost, is basically first calculating slope and then multiplying slope by the slope cost. That one, it's pretty straightforward. The only real tricky thing per se is this con is null. But we've done that now a couple different weeks. Okay, so this is something that you know, if you're going to end up doing a raster manipulation as part of your research or your job, this is a trick that you'll want to learn, because oftentimes you want to convert null values into some other values. So it's a common task that is done in raster GIS processing, is converting null values out into other values. This is the easiest way to do it inside of raster calculator. All right, so that's that. And then the transition cost, we've actually stepped through this together now, and we've discovered that it's a two-step process. The first process is to reclassify, which you could do through a conditional statement. We did it through a reclassify though, is to reclassify land cover so that either of these two values are the same. Does it matter what values they are? No. As long as forest and open are the same value and water is different, you'll be good. So that's the first step. The second step is to do what? What's the next step? What's that?
Identify the.
Yeah, but how do we identify, what tool are we going to run to identify the boundary? Variety. Variety will help us to identify those boundaries. Now that we have the boundary, those boundary cells are going to need to do what? What are we going to have to do with those boundary cells? Right. So the cost to travel through a boundary is going to be this transition cost. Anywhere where the transition cost, anywhere where we don't have to travel through a transition, we shouldn't add anything to the cost. So what should the two values in this value, the final, we have a final transitions cost layer, what should the two values in that be? 0 and, it's not 1, that's a good, 1, if this transition cost was 1, they'd be 0 and 1.
Yeah.
Well, it's whatever, yes, it's 10 in this case, but it's whatever we've put into here. Okay, so there'll be the two steps we ran together, plus there'll be another one, and that other one will be a basically converting this one, the one value here is going to get one value. See, the 1 is the dark blue. What value is 1 going to be in the output? 0, right? We don't want to add any extra costs in areas where there's no transition. In the green areas, the 2 value, what's that value going to be? Whatever the transition costs are going to be, exactly. So, you can do that most likely through another conditional statement. If it's 1, it's going to be 0. If it's 2, now, if you always get this kind of math, you could, and so if you do the steps the same way I did, you could do a raster calculator expression, and you guys could tell me why this would make sense. You could say the output of your focal statistics minus 1 times the transition cost. You see why that would work?
Yes, it turns that 1 into a 0.
It turns the 1 into a 0. And what does it turn the 2 into? A 1. And if I multiply that times the transition costs, what do the zeros turn into? And the 1s turn into whatever the transition cost was. So you could do a conditional statement, but if you think about it, you could also do it a different way. There wouldn't be a conditional statement, but it still work, and it's actually much simpler to type. So you could say focal stats minus 1 in parentheses times transition costs. Okay, so those are 2 different approaches. Either one of them will work.
But we'd be using the focal stats and not the reclassify, right? Not have the focal stats where I made landing for us the same value.
Right.
And then I reclassified that.
Right. So in the model, you should have a reclassify, then a focal stats.
Yeah, so I have both of those. Oh,
Right.
I didn't do my focal stats in the model.
Yeah, just move it into the model. So you will have, most people, unless you think of another way to do this, you should have 3 tools down here. A reclassify, where the input is the land cover. A focal stats, where the input is the output of the reclass. And then finally, a math algebra expression that either has a conditional statement in it or the other method that I just talked about, the minus and the times. Both of them will work.
Do you use reclassify to read and cover values?
Yes, we use reclassify to change the land cover values, but we could have used map algebra and done a conditional statement. But since we're not letting the user specify the elevation data set, it really doesn't. We really don't need to not. We really could use the reclassify, because the user is only specifying these values. So there's no input to that reclassify step that the user needs to be able to modify. That's the reason that we couldn't use reclassify up here, was because there's no way to feed the values into the model. I'm gonna just hit the organize. Whoops. Yeah. All right. Sometimes somebody asks me why it creates these double lines. I think it's because it's in there twice, but it's not always. It doesn't always do that to me. It doesn't always put double lines, even if it's in there twice.
Sometimes it refers to it twice.
Yeah.
It refers to it once.
Yeah, but I've seen it where even if it doesn't refer to it twice, it only puts 1 line. Maybe it's just my monitor doesn't show the lines as well. But anyway, I think that's what it's doing. It just doesn't always seem consistent. All right, so transition costs up here. So finally, we need to add all these together. So there needs to be another map algebra step to add them all together. So, and again, if you were fancy, you could actually put that, if you wanted to, you could put that in the same raster calculator expression. You could say the output of the other one minus 1 times 10 plus these 2 equals the final cost, the total cost. or you can do them as two different steps. No? But so either way, so you'll get your two steps, and then you'll have final costs. All right. Then what do we do? Now that we have the total cost, what's the next step after that? Yes, we need to run the cost distance. We haven't even done that yet. So we run the cost distance model, and the source is going to be the source data set, and the cost is going to be the surface that you create. Okay? All right? And then let's see what... Yep. All right, and then you're just going to run it a few times. Oh, sorry. Then you're going to, after you run the cost distance model, you're going to get the cost distance. Then you need to run the least cost path model and use the destination as the input and the cost distance as the other input. And then you'll get a little line that represents the least cost path traveled between the source and the destination. Okay, and then you could run it a few different times. So I'll hit save. Run this guy a few different times and keep modifying the values and see how that path changes. It is going to take a few minutes to run, okay, especially if you run it on a USB stick. Run it a few times and see how it changes, and see if you can get it to change from like a mostly, depending on the parameters you've chosen, it may go all the way around as an all-water route, or it may go as a mostly over-land route. And so you can change and see how it changes based on different numbers that you put in. Okay, that's under distance, and then it's called, you mean the other one. So you've got cost distance, right? That's the one that finds that's the one you run first, and then that's not it. Yeah, cost path. Yep. Okay, it's cost path. I think it's better least cost path, but this is the one that creates the this is the one that see it even says it's the least cost path, but the tool's called cost path. See, it's going to create those least cost path. This is showing you two different ones with different weight values, which is what you're doing really. You're having two different weight values. So it's the cost distance and then the cost path. Those are the names of the tools. So you run cost distance first. Once that runs, you'll run cost path. So put both of those in your model back to back. Cost distance, then cost path. So there are a number of tools that you have to add in to your model. Where's my model? So you're going to have to add in this one, which we said is probably 3 tools. Then you have to add in another tool to add all the costs up. Then you'll run the cost distance. And then you'll run the least cost path. So that's 6, seems like 6 tools you'll have to add on to this model. I'm going to go ahead and save this model and upload it to the lab so that you can start from you can start it up. Now the problem is that you're going to have to fix all the paths if you do that. If you've been following along with me, it's going to be easier to use your version. But if you haven't been following along, when I upload this, the paths won't work right because it's going to be a different computer. So that. What I could do is I could change the path. Yeah, I'll go ahead and do that. I'll store relative paths and zip up everything, including all the data again, so that you could just delete the data that you have and download the entire thing. So just upload a whole new data package with this installed. Okay. Last thing, I would make the final output also a parameter. So the final output, the final least cost path, make that a parameter so that the user can specify it. You're going to be the user of this model. And you can rename them so that you can bring the, like, you can run the tool, like, let's say this was the model parameter. I saved it. This was the output. Now, let's pretend this was output. I could specify a different path with a different name. I could say run 1, and then I press OK, and it runs through, creates the least cost path. I bring it up, I change a couple of these values, and I call it run 2, and I run it. And then I could run it again, call it run 3. And I have all of those paths. In fact, I could call it run, 2, 3, 5, 1.5, 10 or something, some convoluted name. But anyway, every time I run it, I get a different version, and I could see those different versions. And this is another reason why Model Builder is powerful. So this is another skill that you'll have by doing that, allowing this to be a model parameter, the output. Okay.
We'd add cost path for that.
Yeah, the cost path output would be where you. So instead, right now I just have this set here. I'm going to uncheck this as a model parameter. Your cost path output will be the model parameter because that's the final output. You want that to be able to be modified or changed. The other reason is that then your model can become a full tool that has its own output so that you could link it on to another tool later. Okay? All right.
I think now I understand what is the model parameter.
What the model parameter means. Yeah, that's good. So the model parameters are, like if you've taken a programming course, the model parameters are kind of like in your GUI interface, those are the values that you're letting the end user change. Those are the values that you're letting them specify. Okay? If you don't make it a model parameter, they can't change it. So if we wanted to make our model kind of data unspecific, we could actually let them choose the elevation data and the land cover data. Then they could choose their own data. Okay, but this is actually getting toward, like, you could actually create this model like this, and then publish this model on the internet using ArcGIS for Server. We're not going to get into this in this class, but this is ESRI's ecosystem for doing these kinds of things on the internet. Then you could design a web page where people could come. You could make the source and the destination, let's say, also. So people could come and click a source and a destination and enter in various parameters, and it would draw that on the web. Okay. Now we're not going to teach all that in the class, but that's all in the ArcGIS help. So this is actually the more complicated part, is figuring out what all these tools do. And yeah, it's a little bit overwhelming at first to find out what the con statement does and what the focal statistics do, but that's why we're talking about them in like basic terms, is that, if I want to find out, if I want to do some sort of processing that involves looking at nearby cells, that's a focal statistics operation, and I just need to figure out what tool gives me the answer to the question I want. In my case, the question is, are the neighboring cells similar? If they're not, then there needs to be a transition cost associated with that thing. So I'm sorry I messed up, in calling it, I'm putting the wrong function name when I typed it out in the lab, but that's the reason for it. Okay. All right. So we'll go ahead and stop there, and I'm going to take another little break, about 10 minutes, and then I just need to call somebody about some research I'm doing tomorrow before 5 o'clock, and then I'll come right back in, and I can answer questions on this lab, or I can answer questions on previous labs. Let's go ahead though and stop the video, and then I can upload it to make sure that it works. And then, so yeah, I'll be back in about 10 minutes here.
I'm just making sure you got